Hi, my name is Piff Edwards. I'm a PhD student at the University of Toronto and co-founder of JALI Research. We're super excited to be here talking about how we extended our work that we published in 2016 in Cyberpunk 2077.
Hi, my name is Chris Landreth. I'm an animator and software developer and one of the founders of JALI Research Incorporated. And it's really nice to be back at Siggraph.
Hi, my name is Mateusz Popławski. I am a lead character technical director at CD PROJEKT RED, and welcome to our Siggraph presentation. So, after we finished Witcher 3, which already had pretty good lip sync, we asked ourselves how we can make it better, how we can push the quality without investing hundreds of hours into animation time. For Cyberpunk 2077, we of course decided that we wanted to have better lip sync than The Witcher 3, but we also wanted to add muscle-driven emotional system. We wanted to use that system throughout entire open world game, throughout every character in game. And we needed to support multiple languages, 10 to be exact. And because of huge scope, we couldn't use facial motion capture. To describe this as a picture, we had those two circles, the idea, and I'm gonna tell you how we actually drew the owl. Everything started here at Siggraph. In 2016, I found a paper made by Piff and Chris about lip sync generation. It described a unique feature, something that was exactly what we needed for Cyberpunk 2077. It described an approach how to support multiple speech styles. So anything from whispers to shouts. I thought to myself, that's a good idea, and I just called JALI. It turns out to be a perfect collaboration because JALI had technology, it just didn't have a video game to work on. So we decided to help them out, to flesh out their technology, to make it something special, to make it something that you can actually use in AAA open world video game. And we created something that will change approach how we create emotional driven characters in open world video games. Now fast forward to 2020 and I want to show you our internal handmade benchmark that we wanted to match with a systemic approach. We'll kick off with Judy. She's more of a calm speaker.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Next is Dex, who is a little bit more energetic and mysterious.
Apparently, first thing to burst are the eyeballs. Get a nice clear pop. Then the rest goes goulash.
And finally is Placide, who has a vibe of a dangerous cyberpunk hacker.
10 netwatch scum dead. The grid, BBS is destroyed. But you walk, you breathe. How?
To sum up, I will tell you what components you need to have to create those animations. You need to have speech themselves. You need to have speech styles, anything from whispers to shouts. You need to have eyes, both ambient gains and eye blinks. You need to have a brow movement. You need to support the emotions themselves, so how the face tenses up during speech. And you need to have head and neck motion that ties everything together nicely. Now I'm gonna pass out the microphone to Piff, that's gonna tell you more technical stuff, how we created those components.
The trick to great lip sync is to be undistracting. It is bad lip sync that gets noticed. It's noticed because it's wrong. Great lip sync draws no attention to itself, and instead allows the focus to be on the narrative. It leaves the viewer undistracted while they listen to and engage with the characters. Our lip sync model is well described in our 2016 paper, mentioned earlier. I'll only summarize and point out a few features. The input to our system is a text transcript, a voice recording, and optionally some tags. With this, we generate a phoneme alignment and use audio analysis to gather information on pitch, volume, and speech rate. Our rule-based system determines what lip, tongue, and jaw position is needed at each given phoneme. What is output is speech style and lip sync animation. Chris will tackle speech style shortly. Rule-based methods are open to customization in a way that other AI methodologies, such as machine learned solutions, are not. For example, Mateusz had brilliant insights over the course of our development that I integrated into the speech model in a few few hours or days, depending on what it was. Specifically, there was a line with a sort of leapfrog, she said she loved me, where he suggested the post-alveolar sh should hold over their neighbors. By the next afternoon, we had added this option to toggle on and off, that's a rule on and off. There's lots of those examples. So with this tool, we aim for distillation of scientific research, animation principles, and human insight. Let's look at the clip.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Thanks, Biff. So, in a typical animation pipeline for animating characters in games, what you call the lip sync is done separately from what you'd call facial expression. However, in human speech, there's a lot more going on than just mechanically stringing phoneme poses together. There's an intense amount of expression conveyed in a character's speaking style alone. So in Cyberpunk 2077, we found what we think is an extremely effective way of imparting that expression in the lip sync process. So here's a comparison. Both animations are using the exact same animation on the phoneme controls you see in the middle.
Agreed.
So see how he's hushed in the first part of this line, but explodes at the end of the line, how?
How?
On the left, the ordinary lip sync doesn't convey this explosion, but hopefully you see clearly on the right, it does. So what's going on here? Let's stop on that E in breathe. Now, there are many different ways Placide could have pronounced that E. This square represents all those possible ways. We can distill the facial actions of that phoneme into two separate components, the lip contribution only and the jaw contribution only. All phonemes show up as a combination of these two things on a human face. We can control this combination with something we call the JALI joystick. Right now, Placide is saying this E with a fair amount of both lip and jaw. Now he's saying E, but using only his jaw and no lip. Now E with lips only, no jaw. E with lots of lip and jaw. Now let's change his performance. All jaw, no lip.
You bleed. How?
All lip, no jaw.
You bleed. How?
Lots of lip and jaw.
You bleed. How?
Hardly any lip or jaw.
You bleed. How?
The powerful thing about this joystick is that not only can you set it, you can animate it. Watch it jump when he yells, how.
You bleed. How?
The eyes give life to a rig. Blinks and ambient eye motion make the face seem alive, even when the rest of the face is completely still. So when we blink, why do we blink? There are two reasons. Maintenance, to keep your eyes wet, and cognitive, because you're thinking, and what you're thinking about makes you blink. Our model has three influences: audio analysis of the voice recording, lexical analysis of the transcript, and the time since last blink. The sum of these influences give the timing of a given blink. Let's have a look.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Saccades are the scientific description of the twitchy staccato motions of the eyeball. The processes that influence it are precognitive. The brain just sends the eye around the field of vision to create a scene in the human mind. We have no conscious control of this behavior. Bright lights, faces, and movement are some of the factors that pull the eye around the scene. We have created a statistical model to generate believable pupil behavior. It's important to discriminate. We do not select a look-at point, but after the eyes do the broad motion to the look-at point, we create the ambient deviations to simulate the human perceptual system. Check out the result.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Paralinguals are parallel to speech. They have the same root, the same expressive intention, but are not part of the articulation of the words. Paralinguals play an important supporting role to speech. The biggest of the paralingual actors are the brows. They rise and fall with the speaker's emphasis. Whether they rise and fall is dependent upon the emotional state. Negative emotions furrow and tighten the brow. Positive emotions raise and relax the brow. Analysis of pitch, intensity, and speech rate give us that when and how strongly to animate the brow. To get a sense of character, we make a profile of each, taking in minutes or hours of their performances. Some actors have high-pitched voices, some often speak quickly, others softly. So to tune the automated animation to the character, we use this analysis, the profile, to customize the animation for that character. Also factored in is human input. This can be direct, like changing a setting on a JSync node in Maya with the attribute editor, or come in the form of XML-like tags. You can use these tags to animate changes in the emotional state over the course of a given line. They use the format emotion and percent magnification. For example, here we see happy, 50%, followed by fear, beginning of fear, so wait, what? And then a scream, high, with high fear, all over the course of one line. There's lots to talk about here, but we have to keep it short, so let's play the clip.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
A believable emotional performance is the key to player immersion. Our emotional model has two big parts. Emotion acts as both a still canvas, a background expression which is held until changed, and accents, which appear and strengthen the emotional expression of words when the emotional arousal is peaked. We use audio analysis to determine the emotional arousal level of the voice and then apply the accents when it rises above a certain threshold and drop the accents when the arousal drops below a certain threshold. It's important here that the expression does not interfere with the speech, such as a strong smirk of self-satisfaction should not interfere with the simultaneous pursing of the lips when saying no. All right, let's play the clip.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Like the eyes, you need neck motion to maintain the illusion of life, to see the rig as alive. We started on that premise, that something is better than nothing. We spent a lot of time watching video. We feel that not too much neck motion, just enough. And so the resulting neck model is primarily ambient in nature. Let's have a look.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
Finally, time to put it all together. Here's Judy showing the anatomy of a facial performance animated with JALI. We're showing the layers we talked about one by one.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened.
So, what Chris just showed you is us reaching our benchmark, or something that we consider a benchmark. But the thing is, I wasn't exactly honest with you, because all of those videos that I just showed you are not made by animators. They are not handmade. All of them were created using JALI technology. All of them are fully procedural generated animations without even a single touch of an animator.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing
Apparently,
happened.
first thing to burst are the eyeballs. Get a nice clear pop. Then the rest goes
10
goulash.
networks come dead. The grid, BBS is destroyed. But you walk, you breathe. How?
Every character in our game, every character throughout entire open world, we have this quality of lip sync and this quality of express their emotions. Now, I want to show how this looks in game. Here's Judy.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. You're alive and well.
That was too much. Could feel the guy's pain, his stress, his Hope? Hope wrapped up in something else.
Mm-hmm. Probably took a booster just before. You'll be fine.
I hope you liked Judy showcasing JALI technology. But jest jeszcze jedna rzecz, or one more thing in English. We needed to support multiple languages. And Chris gonna tell you how we did that.
Slow, deep breaths.
Doucement. Respire à fond.
Tief durchatmen.
Respira com calma.
慢慢深呼吸。
Oddychaj głęboko.
Dыши глубже.
Respire lenti e profondi.
Respira lento e profundo.
For each language in JALI, we teach characters to speak using 3 objects: an acoustic model, a pronouncing dictionary, and a grapheme to phoneme or G2P model. The acoustic model predicts the character's phonemes based both on the vocal performance and the text words. All of JALI's acoustic models were trained on datasets of tens, sometimes hundreds of hours of recorded speech and text for each language. The pronouncing dictionary is a table of lexemes that gives all possible pronunciations of words in that language. All of JALI's dictionaries were developed in-house using phoneme notations Alphabet for English and Exsampa for all other languages. The G2P model attempts to provide correct pronunciations for all words not in the dictionary, proper names, gibberish, etc. A good G2P model is critical, particularly for logographic languages like Japanese, and I'm happy to say that our G2P models are extremely accurate. Now, let's look at Judy speaking in 4 of those 10 languages. We want to see not only good lip sync, but a great facial performance in each of these languages. First, English.
Slow, deep breaths. Your cortisol.
I'm stopping on the word cortisol. Judy is stressing this word and her eyebrows furrow slightly right on that word. Now, French.
Doucement. Respire à fond. T'as eu un pic de cortisol et d'adrénaline. Doucement. Respire à fond.
Stopping on the word fond. It's a different part of the sentence than the English version, but again her brows are following her inflections perfectly. Now German.
Tief durchatmen. Deine Cortisol- und Adrenalinwerte sind angestiegen, aber die Hormonblocker wurden aktiviert. Du bist gesund und munter. Tief durchatmen.
Stopping on the word atmet. German is a highly inflective language and her brows respond strongly to that word. Now Japanese.
大丈夫。コルチゾールとアドレナリンが急上昇したけど、ホルモンブロッカーが効いてくれた。あなたの体は何ともないよ。
Japanese is not an inflective language, and JALI responds by moving her brows in only minimal motions. Now, in Cyberpunk 2077, there's an additional challenge with languages, one that's character-driven, which is, what if a character speaks a single line of dialogue in 2 or more separate languages? Placide, for example, is bilingual and does this language switching pretty frequently. We solve this problem by allowing transcript tagging. Now, Piff showed you an example of this tagging earlier, specifically with brow motion paralinguals. We apply a similar approach with language tagging here. For example, here's a line of dialogue in which Placide switches between English and French. The annotation here tells JALI to analyze each fragment of dialogue properly in the language that's specified in the XML markup. And here's the result.
It is called Qui va les lumières, he who swallowed the light.